The construction and demolition of buildings accounts for 1/3 of the global material consumption and waste generation. Did you know that for a country like India alone, more than 35 million new urban housing units will be added over the next 10 years? This will require a huge amount of building materials for the construction. If poorly designed and managed, this will have a substantial environmental impact. Greenhouse gases are emitted and energy is consumed by a building throughout its life. Initial emissions to create the building, including extraction, processing, manufacturing, transportation, and assembly, also known as embodied energy. Recurrent embodied emissions to maintain and refurbish the building, operational emissions for lighting, heating, cooling, and powering appliances, and end-of-life emissions occurring in the demolition and recycling stage. According to the Global Alliance for Building and Construction, cement alone is responsible for 7% of the global CO2 emissions. Steel contributes another 7 to 9%, of which half of it can be attributed to the building and construction sector alone. The construction industry is lagging behind in climate action. The Intergovernmental Panel for Climate Change has urged that appropriate policy action is required to reduce the building's CO2 footprint by 85% from the 2080 levels. This requires all new and existing buildings to be net zero carbon by 2050. As regulations and improvements in efficiency reduce the energy needed to operate buildings, embodied energy becomes relatively more important. If zero carbon buildings become a reality, all attention will be focused on embodied energy. Reaching net zero embodied energy or carbon for major building components such as cement and metals is highly challenging, as these sectors are among the hardest to decarbonize. Most buildings are demolished after 50 to 60 years of use, sometimes even earlier, to pave way for new developments. Construction material and its components are hardly ever recycled or reused. We need to consider the building's life cycle as a closed loop, where the building itself and its components lend themselves to being recycled, reused, and refurbished. This would also save capital and embodied energy directed towards new constructions, reduce the amount of construction waste, and significantly lower the industry's carbon footprint. It will require coherent action along multiple dimensions, from lowering the demand of material and promoting switches to low-carbon materials, to maximizing energy efficiency in manufacturing, and switching away from carbon-intensive sources of energy. There are also significant opportunities in developing systems to lower or avoid the construction waste and enable the reuse and recycling of construction material. What resources do we have? In many tropical regions, clay and earth have been traditionally used as building materials. It's locally available, abundant, perfectly usable for construction, and sustainable. Raw earth is a traditional construction material that has been used throughout the centuries all over the world. Building the walls and foundations with the soil that is ideally excavated on site dramatically reduces the building's embodied energy. Rammed earth, for example, has about 80% less embodied energy as conventional fired clay bricks. Biomass is another material that can meet the technical and the environmental standards. Trees and its derivative products have been used by societies around the world over centuries. Contemporary construction of tall buildings from timber in Huloin parts suggests a growing interest in the potential for building with wood at scale, not achievable previously. It is a renewable source that can be produced and managed through sustainable forestry without negatively impacting the global carbon sink potential. Both resources, earth and biomass, can easily be reused and recycled. They have the potential to create local employment and nurture the local economies. There are also new building materials emerging that can be locally produced and are sustainable. One example are materials that are formed from organic waste and mycelium of fungus. In summary, the environmental and social impact of building materials is expected to increase in the coming decades. Alternatives and technical solutions are available and can be applied immediately. Some emerging materials that are biosourced and locally available will require adaptation and development before being available at scale. Enabling policy frameworks and incentives are needed for the building and construction industry to experience a material transformation with innovative approaches.